Hello, welcome students. This is the channel of Solid Solutions for O and A levels. Today we'll be discussing about the periodic table of elements for O-level chemistry. First, we need to understand why is periodic table very important for O-level chemistry. First of all, we need to understand that each and every topic, for example, moles and the displacement reactions, which we will be learning about each of the properties of the elements. For example, like the group 7 and group 1, we will be discussing them later on. These topics are almost involved in every chapter you will be learning, as moles needs calculation and the calculation depends upon the mass of each element. Hence, the periodic table tells us about the atomic number and the relative atomic mass. The relative atomic mass is the mass of each element, and it includes the sum of protons and neutrons, while the atomic number tells us only electrons and protons. Like, for example, let's take boron. Boron has an atomic number of 5 and an atomic mass of 11. Now, for boron, it has 5 electrons and 5 protons. Now, how to calculate the number of neutrons? As we know, the relative atomic mass is the sum of protons and neutrons. So, like 11 is equals to proton plus neutrons. As we know, protons are 5, so 11 is equals to 5 plus n. So n is equals to 6. It contains 6 neutrons. Boron atom contains 11 is the sum of protons and neutrons. It contains 5 protons and 6 neutrons. I hope you understand that. And it is basically for each and every element that in the periodic table, like the relative atomic mass will be sum of the protons and the neutrons. Now I'm going to tell you about what does the group and the period means. We will be learning in the future about group and the period. The period is not mentioned here, but it is the horizontal component of the periodic table. Just we'll write period. And this is period 1, and this is period 2, and this is period 3, and 4, 4, and 5, and so on. Now, what does the group tell us? Group tells us the number of valence electrons. Now, what does valence electrons means? The valence electrons are electrons in outermost shell. Now, to understand the shells, we know, for example, take lithium Li. You know from the start of the class, it have electrons in the form of shells. First shell, and the second shell, and third shell, and so on. But we know it contains only 2 electrons in its first shell, and then it contains 8 electrons in this outermost shell, and then 8, and then 8, and then I'm just taking lithium for example, but we're going to make a correct electronic configuration for lithium. It goes on from 2 and 8 and 8 and so on. So for really when writing for lithium, we will be we will drawing like this. We know it has atomic number of 3, which means 3 electrons. We have lithium and then a first shell and a second shell. Let me draw it in a correct way. We can take a circle. It has a first shell and then it has a second shell. Now we know only 2 electrons in the first shell and it has 3 electrons. The first 2 are taken in the first shell and only 1 in the third shell, in the second shell. Now this is the correct electronic configuration of lithium. Now what does the group tells us? The group tells us the number of valence electrons, electrons in the outermost shell. Lithium has the outermost shell in its second shell. And how many electrons are there in the in the outermost shell? Only one electron, one valence electron. And if it has only one valence electron, it means it must be in group 1. And what can we see? It is in group 1. And this tells us that all the elements in a particular group, for example lithium, sodium, potassium, rubidium, cesium, francium, all of these would have only one electron in their outermost shell. Now don't get me wrong, they don't always have the same number of shells. They don't always have the same number of shells of electrons. It means it has only 2. It will have 3, and it will be increasing. Now you will be confused. What does the period actually means? The period, let me write it down. The period tells us the number of shells. Now we already know the shells are the places where electrons are rotating. Like this is the shell, and electrons move in this tiny shell, and the electrons move in this shell. Now let's take for sodium. Now sodium has 11 electrons. It has 11 electrons. Now Na, it has first a shell here, and then it has a second shell. Let me make a smaller shell, and now it has almost 3 shells. Now let me just tell you why it has 3 shells. Now we'll draw the number of shells. Now it has 11 electrons, first electron and second electron. It has 11, and now 2 electrons, 2 electrons, 2 electrons, and 2 electrons. We must always know that electrons should be like this. It's the correct way to draw the electronic configuration. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1 electron in the third shell. Now it has only one valence electron, and hence it is in group 1. Now what does the period mean? The number of shells. Lithium is in period number 2, and hence it has only 1 and 2. It has only 2 shells. Now for sodium, it has 1, 2, and 3 shells. It has 3 shells, hence it is in period number 3, in period 3. But as it has only one valence electron, it is in group 1. Now I think so that you have correctly understood what does a group and what does a period means, and what is the meaning of atomic number and relative atomic mass. Thank you. If you like this video, please subscribe and share with your friends. Thank you.